Another important theoretical distribution you need to know about is a chi-squared distribution. Now the chi-squared distribution, as you can see, is defined here. It's the sum of a series of z values squared. You've already learnt a fair bit about z values, and we will use the chi-squared distribution for many things, but the way I'll introduce it, and you'll need to follow the lectures online, the recording of the lectures to understand it, is to compare a theoretical distribution with an actual distribution. Now, if you look down here, it says look at the example 5b. So if we go here, this is the example 5b. Now this is again a made-up example, and the whole idea of this example is to try and work out whether barrier draws make a difference when in horse racing. Now you will all have watched the Melbourne Cup or whatever it is, and you should know what a barrier is. If you're not, just Google it and you'll find out. But the barrier is the starting gate and where the horses start. Made up example here. 6 horse races, just so I don't have too much data here. This says that I observe 120 races. 25 winners came from barrier 1, 22 came from barrier 2, 18 from barrier 3, 19 from barrier 4, 21 from barrier 5 and 15 from barrier 6. Now that looks like there might be some advantage to being close to the rails. Now, assuming there is no advantage, then given that we know that barriers are simply drawn in a randomised process, the expected number of winners from each barrier, of course, would be 20 each time. Okay, that's our expected value, and that's 20 each time, and so that's our theoretical distribution. So we're comparing an actual distribution of winners in horse races here with our theoretical distribution, assuming the barriers make no difference. We calculate the chi-squared using this formula. This is the chi-squared formula here. We work it out. And this number here is what it is. It comes out to, and you can see how that's done. That's the measure of the difference between the theoretical and the actual and the theoretical. And that's 5. Now, there's a whole series of things that you'll need to follow in the lecture notes to understand how you conduct a chi-squared test, but that's telling us that's a measure of difference. Now if I observed, say, 120 races and I had 20 winners from each barrier, then of course this value here you'll find would be 0, and that would imply the barriers make no difference, okay, because the winners are completely uniformly distributed. What about down here? Well, here I'm looking at the same, looking at 120 different horse races, but here all winners come from barrier 1. Okay, there's my theoretical, there's my actual, there's my theoretical, there's my chi-squared. I get a chi-squared of 1,000 here. Now if I observed 120 horse races and found that every winner came from barrier 1, and then I was going to put money on some horse for the 121st race, where would I put it? I'd put it on the one in barrier 1. Problem is the bookmaker wouldn't take my money because he'd know that as well. It'd spoil all the fun. Now clearly in that case it looks like the barriers make a huge difference, and that's the measure. So you'll have to learn about how we conduct a hypothesis test using a chi-squared distribution by following the online recordings of the notes, and that's dealt with here, and that would be the measure. So clearly the barriers make a difference here. Here we're not sure, and if this chi-squared was 0, we would say the barriers make no difference, and that's something you're going to have to follow by listening to the recording of the lecture.